Swayam Prabha. Digital India. Educated India.
So welcome back. So in previous lecture we have discussed many things, many important aspects. Okay. So I'll just recall it. So one was the channel pattern and location, that is for urban settlement. Then we were talking about the precipitation, that is the rainfall. Then we also talked about that, of course, if this is high or it is low, and then we talk about the surface, subsurface geology, which will affect the surface runoff. So these are few things which we were talking about. Now, along with this, the most important part is we need to understand the river dynamics. Where we can talk about the shape of the channel. I am talking about the river channel. Then in this we can further also talk about the carrying capacity, and then before this we can also talk about the dimension of the channel, that is your cross sectional area. This is very important. And then comes the carrying capacity. So for this we need to understand clearly the river dynamics. Now, to understand the floods, it is important to understand the dynamics of the river system. So if you take the longitudinal profile, and this is from the source to where it ends its journey. So this could be either ocean, lake body, or any main trunk stream. So what we see is that it has steeper gradient from the place where it originates. Then the gradient becomes shallower. Close to the mouth, it becomes finer, and this is the place when flow stops. Remaining material is dropped. Of course, in some location over here also the material will be dropped, and this will happen close to the range fronts. That is, range front is here mountain range front, where stream flows from the hilly areas and debouch into the flatlands or the flat plain, flat alluvial So, in our case we have very good example of Indo-Gangetic plain, and you are having Himalayas here. But this you can find anywhere where you are having mostly the hilly terrains. Okay. So, uplands. Now, along with the gradient, change in the gradient, what we can see as the change in the grain size. So, generally particle size may decrease downstream, gradient decrease downstream. However, discharge, carrying capacity and velocity increases downstream. This is true for areas with good rainfall, whereas in dry climatic zones, water loop loss due to evaporation and infiltration result into decrease in discharge downstream. So, most important what we are talking here is the discharge, carrying capacity and the velocity. Of course, along with that the rainfall and in climatic zones, and in which part of this river journey we are sitting at, that is again important. So, that will let us know that whether this region will come under the flooding state or not. Of course, evaporation and infiltration is another important factor which we have also discussed in the previous slide. So, the total flow of stream, we can say that the total flow of water in a stream depends on average velocity of the water times the cross sectional area through which the water will flow. So, the cross sectional area is important. So, if you reduce the cross sectional area by filling up the channel, then this is the new cross sectional area which is left out. And if you keep your precipitation constant, even if you have changed this, then you are bound to see that this river comes very quickly in flooding state, even if the precipitation is comparatively less during that part. So, it is been given as Q equal to VA, where Q is the discharge or total flow, V is average velocity, and A is the cross sectional area. So, this will talk about the width and the depth. So, along with the precipitation, this parameter is extremely important, because if you reduce the cross sectional area, then you are increasing the chances of having the floods very quickly in the region. Now, another very important, most of us must have seen news while during the monsoon season in any area which is coming in the flooding state, and we have very excitingly people will cross the region which is in the, for example, this photograph shows the road has been covered by the flood waters, and we try to cross it and with great brave we show our braveness, and we can easily cross this, but this can result into the that you will be dragged along the water, flowing water. So the lateral force will lift your vehicle easily, and once it has been lifted slightly, and so that will create your buoyancy forces and will drag your vehicle. So in some news channels or the videos, we have seen that even the heavy loaded trucks were being swept away during while they are crossing the roads covered by flood waters. Coming back to again the stream slope and grain size. So in the upper ridges or in the watershed areas close to the source, what we see, of course, we understand that there will be coarser particles which will be carried by the stream. The velocity will be much higher, and as you move further down, the grain size reduces. So the grain size decreases downstream as slope decreases in the stream channel. A photograph shows turbulent high energy taken from Loksa river, which has a steeper gradient and it carries larger grains. And another river has a lower gradient and carries finer particles. So the landforms which are also associated with this two different locations along the same river will vary from place to place. So river system in total, if you take right from its source, what we see is that you have an headwaters, and this is what you are having the longitudinal profile right up to the mouth. So you have tributaries which will contribute the water to the trunk stream, as well as the eroded sediments to the trunk stream, and trunk stream will act as a conduit or a transporting agent which will carry the material right up to its mouth, where you see is mostly the distributaries. So we have tributaries and we have distributaries. So if you put this here, that you have the tributaries joining the trunk stream, and then you are having distributaries. The flow is in this direction. Now, as I was talking, that where exactly you are located, because this part will be the flat area close to the front, or maybe you can go up to this one, and this area is alluvial plain region. This is your upland, your headwaters, and this portion is of course the fluvio-marine area. Mainly you are having the deltas. So what we were looking at, we have the previous slide, we have the main stream, and then we are having the tributaries which are feeding the main stream. And this whole area which it is feeding the main stream is termed as your drainage basin. So main drainage basin of the trunk stream will have subbasins. We'll see later that the shape of the basin the drainage density will play an important role in flooding events. So these are your sub-basins, and the part also we talk this as in the drainage divide. We will come to that in the next slide probably that we have. Okay. So we have a very clear cut demarcation over here. So this if we take this as, for example, there is an east and west. So some of the stream and this main stream, that is, some of the streams are flowing in this direction, some are flowing in this direction. Okay, so flowing in west, flowing in east, and this marks the boundary between that. So this is your drainage basin, or you can say this part, this whole area is termed as drainage basin, and this line, okay, I'll remove this one, and which has been shown out in the yellow, is your drainage divide. So as we were talking about that, we need to understand the river dynamics to understand the flood. For that, we need to also understand the different type of channel pattern. That is that how either it is straight or it is winding up. So this is an example of straight channel where maximum flow depth or the deepest part will be in the center. So this what is been marked by dashed line is your active straight channel, and this portion which has been shown here is your active floodplain. So in total, if we take, we can broadly classify the channel, either it is straight, and the second is the meander, and third is the braided channel. So in one of these slides I was showing from Uttarakhand and Uttarakashi, which talks about that if you have the construction on the outer bend of the meandering channel, it's flowing like that, and this portion is the depositional side, there is an erosive side, it has a tendency to keep carving this part or erode this part, will result into the collapse or cliff collapse because of the undercutting. So we have meandering channel. So one side, that is your outer side, is erosional, and the inner side is depositional. And the braided streams are mostly will have multiple streams which rejoins again or bifurcate into one stream getting bifurcated into multiple streams, and the area between the two streams are termed as your island or braid bars, and in this case what we call this as an point bar. So this is an cutting bank, that is erosive, and then this one is your depositional bank where you will find point bars. Braided channel, so you have braided channel bar or mid channel bar. So what we see is that in straight channel will have the width of the valley will be narrow, but in case of even meander also it will not be much, but in case of braided river will have very wide valley. So I'll stop here and we will continue in the next lecture.